For this assignment, I have the equation potassium iodide plus lead 2 nitrate, which yields lead 2 iodide plus potassium nitrate. First off, we must convert this word equation into a chemical equation. Here we have all of the components, which are potassium iodide, lead 2 nitrate, lead 2 iodide, and potassium nitrate. Nitrogen, oxygen, and iodine are all part of the diatomic element. To convert, we must start off with potassium iodide. Chemical symbol for potassium is K, which you can find on the periodic table, along with iodine. Iodide is an ion which consists of two iodine atoms bound together. Potassium has a charge of K+. Iodide has a charge of I-1. Because of this, they are written as Ki. Now we move on to lead 2 nitrate. Lead can be found on the periodic table as Pb. Nitrate is a polyatomic ion which can be found on the polyatomic chart. Brings us to lead nitrate. Lead nitrate has a charge of Pb plus 2 NO3 -1. Lead has only 1 because when cross-multiplying, nitrate had -1 charge and lead had +2. On the reactant side, we have lead 2 iodide, which is PbI2. To get that, we do Pb plus 2 with I-1 and crisscross, which gives us this. To get KNO3, or potassium nitrate, since we have K plus and NO3 -1, which have the same charge, which is 1, they both have no subscript. This equation is ionic. For reference, potassium iodide is an ionic compound, just as lead 2 nitrate and lead 2 iodide. Although potassium nitrate is ionic, nitrate is a covalent bond. This is the equation with the states. Ki is aqueous, PbNO3 is aqueous, and on the product side we have PbI2, which is solid, and KNO3, which is aqueous. This equation, as you can see, is a double displacement. Here I have placed a skeleton equation which represents double displacement with variables rather than elements. In this case, potassium is A, which starts with iodide and switches with lead. Lead is C in this skeleton example. Iodide is B, which switches with nitrate, or D. Now we must balance this equation. So here we have the equation written out. Now here is a table for the reactant side and the product side. Each letter represents an element, and the number beside it is how much there is on that side of the equation. Now, on the reactant side, we have K1, I1, PB1, N2, and O6. On the product side, we have K1, I2, PB1, N1, and O3. First, there is an imbalance in iodide, where the product side has 2, while reactants has 1. So we start by putting a 2 in front of potassium iodide, or Ki, on this side of the equation. Now, iodide is balanced, but potassium, nitrogen, and oxygen are not. To balance them, we must add a 2 on the product side in front of potassium nitrate, or KNO3. Now our equation is balanced.